Okay, so this video is going to cover complex numbers. Um, it's actually going to be a pretty short video because this topic is not that hard. At least the material you're going to be expected to know for the SAT. So we'll just hop right into it. So it's going to be complex numbers. Okay, so maybe you guys have seen complex numbers before, but it deals with the letter I, right? And basically it states that I is equal to the square root of -1, right? So immediately off the bat, you can say, right, it's a solution for this number, right? Because normally when we deal with x squared, right, we'll say x squared, this makes everything positive, right? Even if whatever you plug in there, if you plug in a -2, right, you get +4, or you plug in 2, you get 4. So we're used to dealing with square functions like x squared as giving us all positive numbers, even if the input itself is negative. But imaginary numbers are different, right? So when you square it, you actually get a negative number, and that's because of the way it's defined here, right? So I squared, right? If I equals -1, I squared, it's just going to be -1 squared, right? And what happens when you square a square root? This goes away, so you're just left with -1. So I squared is a solution for this up here in the box. For x squared equals -1, if I equals x, then I squared equals x squared equals -1. So I would be the solution for that. Okay, so knowing that, right, let's just write down what we know. We know I is defined to be this. And we know I squared is what? Was going to be -1, right? And what's I cubed? Well, I cubed is the same thing as doing I squared times I, right? Because it's just a power of 1 here. But what is I squared? Well, I squared, if we look back at our chart, is just -1, right? And what's left is we have I. So you just have I. So the way we did this, right, we took I squared. We know what I squared is. We know it's -1. We left I just to be I. So this gives you negative I, right? So let's do one more. Let's see if we can go one more so we can get a pattern going. What's I to the 4th, right? Well, I to the 4th is just the same way as doing I squared times I squared, right? Because when you multiply exponents, remember, if you're multiplying exponents, a, where x is any number and a and b are any number, you would get a product of a, x plus b, right? So we're just going to add, this is our a, this is our b, this would be our x here. We would just get I to the 4th. So that's why we can do that. But now let's look. What is I squared? Well, we know it's -1. Right? So it's really just going to be -1 times -1, right? And what's that give you? That just gives you 1. Right? So we have I squared, that's what we get -1. We know that from above here. So we'll do one last more, and then we should have enough to see a pattern. Okay, let's see I to the 5. Well, we know I to the 5, let's see, that is the same thing as doing I to the 4 times I to the 1, right? Because we just add 4 plus 1. What's I to the 4? Well, we just said it's just 1, right? And so what you have left? You have just I to the 1, or just I. So it's 1 times I, or I. So what does that say? That says I to the 5th is I. So basically what happens is that these cycles, right, complex numbers, or I repeats itself. So the first I, you're only going to get negative square root of -1, right? I squared, you're going to get -1. Let's work over here. I cubed, you'll get -I. I to the 4th, you'll get 1. So any number, any I raised to a power, you're going to get one of these 4 numbers. So let's just repeat that real quick. That's really important. So you have I squared, I cubed, and I to the 4, right? So you have -I here, and you get 1. So if you give me any number, and if you raise it to the I, it's going to be this, it's going to be that, or it's going to be this, or to be this, or to be this. It's going to be one of these four numbers here. And I'll show you. Let's do an example. Let's do a really big number. Let's do something like I to the 50, right? What would that be? Well, we know 50, you can do I to the 4 to the 12, right? And you can multiply this whole thing, right? And you can just have I to the squared outside. So let's just break this down. Let's just make sure we know, you guys can see that this over here on this side is the same as this, right? So this is just going to be crucial of knowing our exponent properties. When you have something like this as an exponent, if you have x to the a and you raise that to the b, that's really the same thing as doing x to the a times b, right? So that's all we're doing here, right? Our a is 4 and our b is 12. So I'll write up here for our scratch work, I to the 4 to the 12 is really just I to the 48, right? And then again, what is it multiplied? Well, it's multiplied by I squared. And we know from up here that we have this property and they're being multiplied, you just add them. So this would give us I-50, right? So now that we know that this side on the left is the same as this side on the right, we can start to simplify this. So let's see. So I to the 4, what do we say? Well, we said I to the 4 is just 1. That's what we said here, right? So this is going to be 1 to the 12 times I squared. What's I squared? Negative 1. Negative 1. 1 to the 12th is just 1 times negative 1 equals negative 1. So we just showed this thing with a huge number, I to the 50 is negative 1. And that's how we're going to do these problems. It's going to be really simple. These are going to be some of your favorite problems to do, just knowing how simple they are. So let me see if I can pull this down with me, because this is a important chart here. Okay, so let's do some more problems. Okay, let's see. So now it's asking us to add and subtract. So we have, let's do an example, right? 3 plus 5i, right? Minus 2 minus 3i. What does this equal? Well, we have 3 plus 5i, right? We're going to distribute this negative, so we'll do negative here, minus 2 plus 3i, right? Because this becomes a negative 2, this becomes a positive 3i. So now we're basically distributing, we just need to add up like terms. And when you're adding up like terms, it's almost like you're adding a variable, right? You're not going to add 5i to a positive number, because this isn't a positive number. This is an imaginary number, and this is a real number. So you're just going to add up like terms. This is going to be 3 minus 2, this would be 1, right? So that's done. 5i plus 3i, this is just going to be 8i. So your answer is going to be 1 plus 8i. Now let's do compute the product. Right, let's compute the product. Okay, so if you want to pause the video and try it, that way it's an example and you can come back and see if you get it. Okay, so for this is just going to be distributing, right? So I don't know how you distribute yours. I like to distribute this way. So 4 goes into 5, 4 times minus 2, and then what I'll do is I'll do I times 5, I minus 2i. So I'll do blue first. So 4 times 5 is 20, right? 4 times negative 2i is negative 8i. Now let's do our green. I times 5 is plus 5i, right? I times negative 2i is negative 2i squared. Okay, so now let's add up some like terms. So 20, right? There's no other constants, so we'll bring our 20 down. Minus 8i plus 5i, negative 3i, minus 2i squared. Okay, so what's our I squared? Remember, I squared, if we look at our chart, I squared is just negative 1. This is going to be negative 2 times negative 1, right? Because that's all this is here. So now what we'll do is we'll do 20 minus 3i plus negative 2 times 1 is plus 2, right? So now what we have to do is add up more like terms, so you get 22 minus 3i. That would be your answer from this, right? So this whole thing here is going to be that when we simplify. Let's do one more. let's see. So which of the following is equal to 2 plus 3i over 1 plus I? So they give us a 1 half minus 1, b, c, or d. Right? So they're going to give us one of these three, or one of these options is going to be equal to this. So you want to go ahead and attempt, pause the video and come back. Okay, so with this, what we're going to be dealing is we want to get a real number. You notice on each of these answers, there's no I on the bottom, right? This would be multiplied by I, but really that means this I is on the top part of these fractions here. What do we have here? We have an I term on the bottom. We want to get rid of it. So whenever you do that, you need to multiply it by something called the conjugate. So the conjugate, C-O-N-G-U, conjugate. Right? So whenever you're given a conjugate, all you need to do is you just flip this term. This term just becomes, if it's positive, it becomes a negative, or if it's negative, it becomes a positive. So in our case, this is positive. So what we're going to do is multiply the top and multiply the bottom by the conjugate. Right? So that's all you need to remember. Right? If you see something and you need to clear the bottom, if there's no I term in the bottom, just multiply by the conjugate, which is switching the middle term, and you're good to go. And if you notice, we're multiplying really by 1, so we're not changing this here in white at all, because this is just the same thing on top, same thing on bottom, and anything on top that's the same, it's just 1. So we're really just multiplying by 1. It may look like we're going to change this function, or sorry, it may look like we're going to change this expression a lot, but we're really not. Okay, so let's multiply this. So you have 2 plus 3i times 1 minus I over 1 plus I, 1 minus I, right? So we multiply this. I'll do this real quick. This is going to be here to here, so it'll be 2 minus 2I, be here to here, this will be plus 3I minus 3I squared, right? Minus 3I squared. On the bottom, what's the bottom? This to there, 1 times 1 is 1, right? Minus I here to here. This is plus I, and then this is minus I squared. Okay, so I'll write it down here. So I have 2 minus 2I plus 3I minus 3I squared over 1 minus I plus I minus I squared. Right, so now we got to simplify it. Let's look at our like terms. This cancels, right? Now let me do a different color. This cancels, right? So now you have 1 minus I squared. I squared is what? Negative 1, right? So we have 1 minus I squared minus 1. So be careful, that's not a positive one, because that would make this whole thing undefined. So on the bottom, you'll really get, instead what you'll get is 2, right? So here, this whole thing is going to be 2 on the bottom. So our new fraction is going to be 2, then you're going to have all this stuff on top. So let's look at what we have here. We'll have our 2, right? We have minus 2I plus 3I. This is just going to be plus I. Minus 3I squared, again, minus 3I squared is negative 1. So we simplify that, we'll get 2 plus I minus 3 times, it's going to be plus 3, right? Minus 3 times negative 1 over 2. What does this equal? This equals 5 plus I over 2. And if you guys remember, we can break up this fraction, right? If we have a fraction of this form, I can break it up by saying A over C plus B over C, right? This is the same thing. So if you see something like this, you can convert it into this. So we have something like this. This is our A. This is our B, right? This is our C. So what we're going to do is we're going to do 5 over 2 plus I over 2, right? That's what we're looking for. So we only see one of those, right? What does that look like? D, right? So remember, if you want to get rid of an I term on the bottom like this, you just got to multiply by the conjugate. And the conjugate is you just switch the term, right? So for example, the conjugate of this is just going to be 1 plus 2I. So yeah, knowing the conjugate is going to help you a lot. And really, the biggest thing is knowing that I equals square root of negative 1. I squared equals negative 1. I cubed equals what? Negative I. and I to the 4th equals positive 1. Knowing this is going to be essential for doing these problems. And you can simplify a lot of stuff for it. So we're going to do 2 more practice problems, 3 more, because it's, like, the section is short, because they don't expect you to know that much on complex numbers. I think they try to trick you up by giving you stuff like I to the 24, and they say, okay, figure it out. And it's like, well, it's actually not that tricky if you know this table here, right? So let's do this one, for example. We just came up with this one on the top of your head. And this is something that you guys should try to practice, right? Try to come up with something. So we know this is I to the 4. The idea is you want to get it in one of these terms, right? You want to get it into one of the ones you know. So I to the 4, and preferably one of these, right? A 2 or a 4. So I to the 24 is the same as I to the 4 to the 6, right? Because 6 times 4 is 24. So this is really 1 to the 6, or just 1, right? Let's try an odd one. So I to the 31, right? So this is the same thing as saying, okay, I can do I to the 30, which will give me, and it times I to the 1, because I can add these two. Well, what's I to the 30? That's the same thing as saying I to the 2 to the 15, right? Times I to the 1, right? 15 times 2 is 30. Well, what's I to the 2? It's negative 1. So this is the same thing as saying negative 1 to the 15 times I to the 1, right? And since this is an odd number, right, and this is a negative number raised to it, it's going to be negative. So you're really going to get negative 1 times I, which is the same thing as negative I, right? So again, that's kind of what these are going to be the trickier ones you'll see on the SAT. They're trying to confuse you, but if you have that table and you're comfortable with exponents, these are going to be easy points. Okay, let me see if we can find okay, so find, what does this equal? I to the 4 plus 3I squared plus 2. What does this equal? Okay, so pause the video and attempt to solve it. Okay, so hopefully you came back from this video, and if you have that table, this is going to be really easy, right? I to the 4 is 1, so this becomes 1 plus 3I squared. What's I squared? This is going to be plus 3 times negative 1, right? This comes down to plus 2. So this is just simply going to be 1 plus 2 is 3 minus 3. This is just going to be 0, straight up. So that's not bad. Let me see. Let's do another. What's a tricky one? I'm looking for one that's worth putting on the video. Oh, this one's 6. So we're given this 6 plus 2I times 2 plus 5I, right? Put this in form A plus BI. What is A? So basically this question can try to confuse you if you don't know what this form is, right? All it's saying is that some real number and then some number in front of the I term, right? So of course you're given this and you want to simplify this. You're saying what's going to be that real term here. So let's simplify this really quick. So of course we'll distribute 6 times 2, 6 times 5I. This would be 30, or sorry, jumping ahead here. 6 times 2 is 12, plus 5, or 6 times 5I is going to be 30I, right? We're just multiplying like normal. You can think of I almost like an x when you're multiplying by regular numbers. 2I times 2 is going to be plus 4I. 2I times 5I is going to be plus 10I squared. Right? So we're not quite in this form, A plus BI, as we have an I squared here. So let's deal with that. This is going to be plus 10. We know I squared is negative 1. Let's combine these. It's going to be 34I, and this is finally going to be 12. So it's going to be 12 plus negative 10, right? Because 10 times negative 1 is going to be 12 minus 10 plus 34I, or 2 plus 34I. So what's the A part? Well, the A part is A equals 2. And what's B? Well, B is 34. So you wouldn't say B is 34I. B is the real number here. B is going to be just this number, not I. Okay. Actually, that's about it. I'm gonna post some more. Like I said, complex numbers should be a topic you guys hope they put a lot of questions on for the SAT because it's really not that bad. Knowing the table is going to be crucial. And anyway, I hope you guys enjoy it, and I'll post some questions and then the solution video. Okay, have a good day.